Hey, this is Leach with Simpson Math, and in this video, we will be looking at a special GCF and talk about factoring by grouping. This is also part of a series of videos which will serve as a fundamental review of factoring geared towards college algebra students. And in the next video, I will show you how to factor using the AC method. So let's get started by finding the GCF of 9xy plus 5y. What do you think that is? So looking at this, I have a 9 and a 5. There's nothing in common there. I have an x and nope. But I have a y and a y. So my GCF is y. So it should be pretty comfortable factoring out a y. We just did this in the last video. So pull out a y, and I've left inside a 9x plus 5. And as always, do your quick mental distribution double check. Now, I said that this was a special GCF, so here's me making it special. So, but now, me, your professor, me, the person who's making this video for you, I'm going to change the y into an x minus 4. So, not much should change. So all I'm doing is literally just erasing the y and writing an x minus 4. Erasing the y over here and writing an x minus 4. So let's look at that. So if I see this, and I need to factor out a GCF, what's the GCF of this? Well, before I made the change, it was just y, right? So after I make the change, wouldn't the GCF still just be x minus 4? It is, right? This is 9 times x minus 4. And 5 times x minus 4. So the x minus 4 is a factor by itself, multiplying these other things, and it is the common factor. So I can factor out the x minus 4. So notice I have this y again, scrub it out and rewrite and put an x minus 4 in its place. So now it's x minus 4 times 9x plus 5. So if you look at this, I'm factoring out a GCF, but this GCF is a binomial. Kind of neat. All right, so let's take a look at this next one. So I have 5a times a minus 2b minus, oh, there's a minus this time, c times a minus 2b. Well, what's the GCF of this? Well, the GCF of this is a minus 2b. You can even throw parentheses around it if it makes you feel better. So the GCF is a minus 2b. They both have a times a minus 2b in common. So if I was to divide an a minus 2b out of this one, that reduces to 1. If I divide an a minus 2b out of this one, it reduces to 1 and leaving just a minus c, right? It's just a bigger GCF. So I'm going to factor out and write it on the outside here. And left inside, and again, this is, you can think of this as inside, we have that 5a minus c. This is bothering you, rewrite it for just a second as 5ax minus cx. Well, in that case, I would factor out the x, and left inside would be 5a minus c. All that I've changed is instead of writing x, I'm writing parentheses a minus 2b. And so again, you can think of this, that 5a minus c is being left inside, and this is just the thing that's the GCF. All right, so this is very, very, very important. So I want you to practice this using these two. So factor out the GCF from these two problems. Pause the video, try these two on your own. All right, let's take a look at this first one. Well, the GCF is this 3x plus 2. So I could factor it out, so it comes out, and I have it out here, left inside. If you want to write them right now a little bit bigger, parentheses, inside is an x minus 3. And again, if that bothers you, if this was xy minus 3y, well, a y would just come out, and I would have left inside an x minus 3. So just replace the y with 3x plus 2. With parentheses. Those parentheses are absolutely required. All right. Last one of the quick fire. the GCF is x plus 6, so pull out the x plus 6. And what's left inside? Well, my 2x, but this is a minus 1. You can think of this as a negative 1 times x plus 6. Or if I just had a negative x plus 6 divided by x plus 6, this reduces to 1. That negative is still there, so this equals negative 1. So that's why we have this negative 1 here. Again, if that bothers you, 2xy minus y, pull out the y, that's the GCF, and you should be from our previous video okay with saying that that's minus 1. All right, so there's that important idea. So this is our special GCF. It's just a special type of GCF that is a binomial. So picking up from this example, let's look at this. So let's distribute this into something. So let's distribute this and look at something. So if I take this right here, and I did switch them because I'm a teacher and I want to do that. So I did switch them. So I'm going to distribute. So if I distribute this, I would distribute the 5a times a, 5a times 2b, or even just simply 5a times this entire binomial, and a negative c times this whole binomial. Let me pause there, and I want you to notice this is what we started with. That's why I swapped the two so that you would see that. To take the 5a times that binomial, because then our next step would be we could then distribute this and get these two, right? Does that make sense? I know you wouldn't really ever stop right here, but that's what we're doing. And then this negative c times this binomial, which is right here. So we started here and factored to there. So couldn't we start here? And you go ahead and finish that distribution. 5a squared minus 10ab. This is negative ac plus 2bc. So couldn't I have started here and then found my way to this? That's the big point of what we're making here. So I'm gonna show you a procedure called factor by grouping that would allow you to start with these 4 terms, find what this is, and then produce these 2 binomials. All right? So let's do it. So sometimes, big ol' sometimes when there are 4 terms, has to be 4 terms, we could factor by grouping. So let's look at this. If I have AB plus AC minus BD minus CD. So step 1 is to, and I do have this above my head right here, the steps for factoring by grouping. Step 1 is to factor the GCF out of the first 2 and out of the last 2. For some reason, this on the screen is coming across as like a light yellow. It's a green on my paper. Shrug. So when I'm looking at this, from the first 2, so I'm just looking at the first 2, temporarily, those other 2 are dead to me. So what's the GCF of AB and AC? Well, it's an A. And so if I pull the A out, factor the A out, I'm left with a B plus C. Then the first 2 are dead to me, and I'm just looking at the second 2. So if I have a negative BD and a negative CD, what's the GCF of those 2? Well, first, the leading term has a negative, so I gotta have a negative for my GCF. And well, they both have a D, so negative D. And when I do that, I'm left with a B plus C, because the signs change because I divided out a negative. So now look right here. This is what we were looking at for the last several examples. I have these 2 terms, so I started with 4 terms, did these GCFs, and now I have 2 terms. These 2 terms both have a common GCF of B plus C. So step 2 is to factor out the binomial that now should, not will, should be another GCF. So just notice, if this D was, let's say, Z, something completely different, would this have worked? No, there wouldn't have even been a common, other than a negative, there wouldn't have been a common GCF here, and these things would not have looked the same. So we are under no impression that we are guaranteed that just any 4 random terms that this will happen. So it's certain 4 terms. So again, so I'm going to factor out this b plus c, and then left hand side is the a minus d, like we saw in our previous examples. All right, so I want you to try these on your own. So we have 2 steps. The steps are above my head. Factor out the first 2, factor out the second 2, factor out what's remaining. So do these 2. When you work on the second example, yes, these 2 do add. Don't combine like terms. Just do the factor by grouping. So pause the video and factor these 2 by grouping. All right, so let's see how you did. So from the first 2, I see that there is a common x squared. No numbers. This is a 2 and a negative 3. They don't have anything in common. The leading coefficient is positive, so I'm not going to pull out a negative. But this has x times x times x. This one has x times x. So this has 2 x's in common. So they each have 2 x's, have at least 2 x's. The first one has 1 extra. And we see that 1 extra left inside right there. All right, over here, this is a positive 4 and a negative 6. They're both even, so I can pull a 2 out. This has an x, this one doesn't have an x, so the x's don't come out, so a 2 comes out. But oh look, a 2x minus 3 is left inside. As this is something that should not surprise you at all, because we are studying right now, factoring by grouping. We'll have a 2x minus 3 left inside on both. So at this point, from these 2 terms, we now have a GCF of 2x minus 3. So I'm going to factor out this 2x minus 3, and left inside is x squared and 2. One note about this color coding business. So I am doing a little bit of color coding just so you can help you see. You might be able to see it's very faint on my screen right now, but there is a bit of a blue right here. So when it comes to color coding, I'm okay with the color coding. If you want to use some sort of like maybe squiggle or something, do be careful with just like drawing lines, because that could start looking like division lines, division bars or something. But if you want to maybe put I'm erasing. If you want to maybe put, if you don't have colors, a little like underneath bracket, that's cool. You might have had a previous teacher, or you might have seen somewhere, or sometimes just students think, oh, I'm going to put parentheses around things. You may not put parentheses, just throw in parentheses to try to say I'm grouping those 2 up. Very, very, very bad idea, as you'll see in this next example. So let's take a look at the first 2. The first 2 have an x, and that's it. So I can pull out an x, and I'm left with, if I divide an x out of there, I just have 1x, no x's, left with an x plus 6. So over here I have a negative for the leading term, because I'm just looking at these second 2. And you could put a little underneath square bracket like that. So you could draw a little faint underneath square bracket. I'm okay with that notation. You're just saying these 2 are grouped up and these 2 are grouped up. Leading term has a negative, and they do both have a 9 in common. 9 goes into 54 6 times. And it's a negative divided by negative is a positive. Again, lots of little GCFs, so just do those double checks. Negative 9 times x, negative 9x. Negative 9 times 6. Negative 9 times 6 is a negative 54. Yep, we're good to go. So here's why it's important. I'm okay again with the little small square brackets. If you start throwing parentheses around things, this is a problem right here. Students sometimes will then think, I can put parentheses. Which, again, if you're just now joining me, parentheses, do not do this. This is a very bad idea. Now all of a sudden I am subtracting this negative. These parentheses mean something. This would say distribute this negative into there. That changes the value of this. This is a big no-no. So you might be like, well, Mr. Sassy Pants, I'll just do this. No, you just created something that looks like this. That's 2 binomials being multiplied by each other. Again, you just changed the value of the problem. Parentheses mean something in math. So you can't just be throwing them around. You can't just be grouping them up. So either do nothing, or color code with highlighters, or if you don't have those options, you can put, or maybe a little bit wider there so you can grab that negative, put little light square brackets underneath if you need to physically show a separation. Okay, so yeah, that's factor by grouping. In our next video, as you see, we're going to move on to talking about the AC method, which culminates, the last step of the AC method is this grouping, factor by grouping technique. So Join me in the next video when I introduce factoring by the AC method.